Hello and welcome to ICND1 Lab 9, which shows how to configure RIP with default version settings, as well as how to configure a network of 3 routers to use RIP version 2. For those of you using the Cisco Press exam certification guides, note that the material covered in this video is also covered in the ICND1 books, Chapter 14. This lab has 4 main objectives. First, this lab will examine how to configure the RIP network command, so that by the end of the lab, you'll be able to describe how a router interprets the network command and what it does on each interface that matches the network command. We'll also focus on the Show IP Protocols command, and by the end of this lab, you'll be able to describe some of the key information that you see in the output of that command. Finally, this lab will compare the default RIP behavior in regards to RIP versions and compare that to a router that's been configured to use just RIP version 2. This lab uses 2 main scenario steps to demonstrate RIP configuration. The first step shows how to configure RIP while ignoring the version settings so that a couple of routers are using the default version settings. In the second step, we'll see the effects of the mismatch version settings on the routers that use defaults versus a router that's configured for version 2, and then see the steps to migrate so all routers are using version 2. Let's start step 1 by taking a look at the IP addressing and the topology used for this part of the lab. As you can see, router 1 has a LAN interface with IP address 172.22.11.1, as well as 2 WAN interfaces that are connected up to routers R2 and R3. Additionally, R2 and R3 each have a LAN interface that's been configured with an IP address shown there, and router 2 and router 3 have a serial link between each other. Now, this particular lab starts with all those IP addresses configured, all the interfaces up, and with router 3's RIP configured. Router 1 and router 2, to start this step, do not have any RIP configuration. Next, consider the subnet shown in this figure. This figure will have 6 subnets, and each subnet happens to use a mask of 255.255.255.0. That way the math will be pretty easy and you can focus on the RIP configuration. So in this case, notice the LAN subnets will be 172.22.11, 12, and 13 as shown here, and the 3 serial links will have subnets 172.22.112, 113, and 123. Once RIP is configured and up and working on all 3 routers, each router will have routes to reach all 6 of these subnets. Next, let's take a look at the RIP configuration. The RIP configuration starts out with the router RIP command, which puts you in RIP configuration submode. Then the network command tells the router on which interfaces to enable RIP. However, the network command is a little bit indirect. The network command, as you see here, has one parameter called the network number, and that is the class A, B, or C network number. Now, what the router will do then is interpret that network number and ask itself, which of my interfaces are in that network? For any interfaces that are in that class A, B, or C network number, that router does RIP on that interface. Doing RIP meaning sending RIP updates, listening for incoming RIP updates, as well as advertising about that connected subnet. As an example, consider the RIP configuration shown here, which is the configuration we're about to add to router R1. Notice the network command doesn't list an IP address of an interface, but a class B network number. That's a requirement of the network command. Now router R1 looks at that network command and says, oh, which of my interfaces are in that class B network? And it notices that all 3 of the interfaces shown there are in that class B network. So as you see there, router 1 starts sending RIP updates on all interfaces. Router 1 also listens for incoming RIP updates on those interfaces, as well as advertising about the subnets connected to those interfaces. Next, let's move on to the command line interface portion of step 1 of this lab. We'll start this lab with router 3 configured for RIP, and router 1 and router 2 needing to be configured. Now before we get started, notice if we do the show IP route command on router 1, we see 3 connected routes. Notice the C in the far left hand column, and notice in the legend at the top it says C means connected. So router 1 knows 3 connected routes, but it doesn't have any RIP learned routes that would show up with an R. Now for reference, if we do a show IP interface brief command and look at that output, notice we see a line for our fast Ethernet 00 interface, which is up and has an IP address, and for our 2 serial interfaces, both of which are up and have IP addresses. However, you're probably going to want your booklet open to the reference page that shows IP addresses when you're looking at the command line interface output. Next, let's add the RIP configuration to R1 as we just saw in the previous example. So we'll go into config mode, type the router RIP command. Notice that the config mode prompt has changed to config-router, meaning we're in router configuration mode. And next we'll type the network 172.22.0.0 command and press enter. At this point we've enabled RIP on all three of the interfaces on router 1 because all three interfaces are indeed in network 172.22.0.0. Now let's go confirm that the RIP configuration worked on router 1. If we do the show IP protocols command that you see here and look at the output, there's a few interesting things here. First of all, by default, RIP sends version 1 updates and is willing to receive both version 1 and version 2. So notice here on our three interfaces we expected to match, FA00, Serial 010, and 011, we see that this router, router 1, is sending version 1 updates and willing to receive both version 1 and version 2. Now if you look a little further down, we see routing information sources listed, and we see a gateway IP address. That IP address that ends in 113.3 is indeed router 3, and that says that we're receiving RIP updates from router 3, and it shows how long ago that we last received an update from router 3. So from this command, we can tell that RIP on router 1 is learning routing information from RIP on router 3. You can also verify that RIP is working on R1 by using the show IP route command. If you look at the output here on router 1, notice now there are two routes that have an R in the left-hand column. That R means that these are RIP learned routes according to the legend information that you see toward the top of the command. Now if you look at both routes carefully, notice there's a VIA field. That's the router from which this router R1 learned these routes, and the VIA field points to 172.22.113.3, which is router 3's serial IP address. So this command verifies that R1 is indeed learning RIP information from R3. To finish step 1, we'll go over to router 2 and complete the configuration. Remember, router 3 was pre-configured for RIP. We just configured router 1, so now in router 2 we'll get into configuration mode, type the router RIP command, which puts us in RIP configuration mode, type the network 172.22.0.0 command. By doing so, we told router 2 to do RIP on all three of its configured interfaces. Now let's go back to R1 to confirm the RIP configuration on router 2. If you look at the output of the show IP route command that you see here, you'll notice that there are 6 subnets shown in the routing table now. The one that was formerly missing before we configured R2, R2's LAN subnet of 172.22.12.0, is highlighted here on the screen. Note also for this route, the VIA field in that route shows 172.22.112.2, which is router 2's WAN IP address. So in this case, router 1 has indeed learned a route from router 2, as we can see there. Also, if you do the show IP protocols command again, and you look toward the bottom where the routing information sources are listed, notice now there are two gateways listed, 172.22.112.2, which is router 2, and 113.3, which is router 3. So this is yet another confirmation that now router 2 is using RIP and sending RIP updates here to router 1. Next, let's move on to step 2 of this video. As we saw earlier, both R1 and R2 have identical RIP configuration, with the router RIP command followed by network 172.22.0.0. Now earlier we saw in the output of the show IP protocols command the default version settings. And those default version settings said that both routers will send version 1 updates only, but they'll be willing to receive both version 1 and version 2 updates from other routers. The part that I didn't mention earlier was that router 3, while it was already configured to support RIP, it also is configured with the version 2 command as you see here. As a result, router 3 doesn't use the default version settings. Instead, with the version 2 command configured, it only sends version 2 updates, and it will only process received version 2 updates, ignoring any received version 1 updates. Next, let's consider what's been happening in this network at step 1, with router 1 and 2 using default version settings, and router 3 configured for version 2. Router 3 sends only version 2 updates, not version 1 updates, but because R1 and R2 are willing to receive and process version 2 updates, they receive the updates, process them, and they learn routes, just like we saw earlier in this video. However, say router 1 starts to send an update, it only sends version 1 updates. It does not send version 2 updates. So when R3 receives that update from router 1, router 3 simply ignores the updates. Similarly, when router 2 sends its RIP version 1 updates, router 3 also ignores those updates. So right now, router 3 should not be learning any routes either from router 1 or router 2. So for this final scenario step, we'll turn our attention to the command line interface, first confirming that indeed router 3 is not currently learning any routes, and then solving that problem by migrating both router 1 and router 2 to use version 2. So let's take a look at the command line interface starting on router 3. If we do a show running config command here, and page down a little bit, we get to the RIP configuration. Note here there's a router RIP command and a version 2 command as well as a single network command. This network command matches all three interfaces on router 3, and the version 2 command tells this router, of course, to just send and just receive version 2 updates. Next, if we do a show IP protocols command and look at the version information, see here that it says router 3 will send version 2 and receive version 2. And in fact, on all three interfaces, it will just send version 2 and just receive version 2. Now, to confirm that router 3 is not currently learning any routes, if we take a look at the show IP route command, notice there are only 3 routes listed, and all 3 of them have a C beside them on the far left column, which means router 3 only knows its 3 connected routes. To fix this problem on router R3, we're going to switch back over to router R1 for a moment, and we're going to configure it to use just version 2. To do so, we first get into configuration mode on router R1, then use the router RIP command to get into RIP configuration mode, and then issue the version 2 command. As soon as I pressed enter at the end of the version 2 command, that told R1 to just use version 2. If we repeat the show IP protocols command here on router R1, you see here now that it's only using version 2, only sending version 2, and only receiving version 2 on all 3 interfaces. At this point, both R1 and R3 are configured to use only version 2. Now I need to complete the process of migrating to version 2 by configuring router R2. So moving over to router R2, we get into configuration mode, use the router RIP command to get into RIP configuration mode, and simply add the version 2 command. Yet again, the show IP protocols command here on R2 confirms that on all 3 of R2's interfaces, it's only sending version 2 and only receiving version 2. So the question is, did this really help R3 or not? So if we switch back over to R3 and take a look first at the show IP protocols command output, notice that instead of having no update information sources, now toward the bottom of the output of this command, it shows 2 routing information sources. The address that ends in 123.2 being router R2, and the address that ends in 113.1 being router R1. Additionally, if we do a show IP route command, note here that R3, instead of only knowing 3 connected routes now, notice it knows about 6 subnets. And if you look at the far left, you see there are 3 different routes that are learned via RIP, because the R on the code on the left means learned via RIP. This concludes IC&D 1 Lab 9. In this lab, you'll learn how to configure the RIP network command, as well as how to understand and interpret what the RIP network command really does. You've also seen how to interpret some of the key information that's found in the show IP protocols command output, and you've learned how to compare the default RIP version behavior, which tells a router to only send version 1 updates, but be willing to receive either version of update, as compared with a router that's been configured to just use version 2.